नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विशेट्टी, फैकल्टी ऑफ माइक्रो प्रोसेस। मैं आप सब लोग को हमारा यूट्यूब सीरीज को स्वागत कर रहा हूं। माइक्रो प्रोसेस गेट इंस्ट्रूमेंटेशन लोगों के लिए है, स्पेशली गेट इंस्ट्रूमेंटेशन पीपल के लिए माइक्रो प्रोसेस है सब्जेक्ट। हमारा ईसी पीपल को माइक्रो प्रोसेस नहीं है, लेकिन गेट इंस्ट्रूमेंटेशन के लिए माइक्रो प्रोसेसर है। सो अगर ध्यान से देखें तो माइक्रो प्रोसेसर में क्या क्या कंटेंट आने की चांसेस है, आज हम डिस्कस करेंगे। Okay, so first of all we'll discuss the microprocessor. What is a microprocessor? Microprocessor is a CPU on a single chip. Okay, so फटाफट जल्दी से जल्दी ज्वाइन कर लो बेटा। जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। सो ये यूट्यूब का क्रैश कोर्स है, माइक्रो प्रोसेस फॉर गेट इंस्ट्रूमेंटेशन बच्चों के लिए है। सो गेट इंस्ट्रूमेंटेशन बच्चों के लिए ये टॉपिक हम डिस्कस करेंगे। क्रैश कोर्स फॉर गेट ईएससी प्रिपरेशन, इंस्ट्रूमेंटेशन इंजीनियरिंग। डोंट कंफ्यूज, दिस इज नॉट फॉर ईसी, this is not for EC, my dear. This is not for EC। जितने लोग लाइव में हैं मुझे एक बार ऑल क्लियर है या फटाफट क्वेश्चन स्टार्ट करेंगे। सो जितने लोग लाइव में हैं चलो, what is your idea of microprocessor? Anybody from instrumentation here? Anyone from IN students? IN category or ESC category? ESC category. So type here. Chalo. Now let us discuss what is microprocessor and what is the weightage of this in our upcoming topics. So if you see the topics, especially for gate instrumentation plus and IES ECE, IES for ECE, electronics and communication for electrical and electronics engineering. So the syllabus is 8085 microprocessor, instruction set and memory interfacing. So these are the syllabus. Next, the syllabus for 8086 basics, 8086 microprocessor basics and 8051 microcontroller basics. For gate instrumentation, it is 2 to 4 marks. But for IES, EC and EE both, it is 40 marks. Okay, both conventional and objective milake. Okay. So now, how many of you are there in the live? Please let me know. I will start the questions. Chal. Now, let us start from the fundamental definitions. First of all, what is microprocessor, what is microcontroller? We start from वहां से हम questions के बाद जाएंगे. Okay. So what is microprocessor definition? Microprocessor definition is, it is a CPU on a single chip. So it can perform only arithmetic logical operations, instruction set. Okay. But for the microprocessor, the memory input output all are variation, all are different. They are not inbuilt. Okay. So definitely this microprocessor needs interfacing of the memory. Microprocessor needs interfacing of your input and output devices. So you have to understand the clarity concept of microprocessor and microcontroller difference. So if you see the difference, microprocessor and microcontroller. So 8085 microprocessor will be interfaced to memory, input and output devices by using the bus. Whereas microcomputer, when you are interfacing all these things with microprocessor, RAM, ROM, IO ports, then it is called as microcomputer. So microcomputer definition is, microprocessor is a part of it, memory, external peripherals, microcomputer, examples calculator and motherboard. Okay. So अगर ये पूरा एक particular chip पर fabricate हो गया, then उसको हम बोलते हैं microcontroller बोलते हैं. So microcontroller का definition है microcomputer on a single chip. ये पूरा microcomputer fabricated on a single chip, उसको हम microcontroller बोलते हैं. उसका example है 8051. आपका academics BTech second year और third year में अगर आपको ये नॉलेज है 8085, 8086, 8085 नॉलेज है, गेट एंड आईएएस में आप आंसर कर सकते हैं. ओके, सो माइक्रो प्रोसेसर, रैम, रोम, IO ports, serial data communication, and timers and counters, they all fabricate in the smallest chip, then that is called as microcontroller. So microcontroller is treated as ASIC. ASIC. Can anybody type what is ASIC? Can anybody type what do you mean by ASIC? Can anybody type what do you mean by ASIC? ASIC का मतलब क्या है? What do you mean by ASIC? ASIC का definition है, ASIC is treated as application specific integrated circuit. Application specific integrated circuit. So whereas microprocessor is GP stands for general purpose. It stands for general purpose, and microcontroller is called as ASIC, application specific integrated circuit. Chalo, now let us go for some basics of 8085. 8085 is having 8-bit data bus. 8085 is having 8-bit data bus. It is having 16-bit address bus, 8-bit data bus and 16-bit address bus. And these are the terminology. Bit means 0 and 1. Nibble means 4 bits. Byte means 8 bits. Word means 16 bits. 1 kilobyte means 1024 bits. 1024 bits here. This is not bytes. 104 bits. Okay. So, chalo, note down. Make it fast. Okay. Chalo. So how many data lanes it is having? It is having 8 data lanes and it is having 16 address lanes. So can anybody tell me, if 16 address lanes are present, how many number of memory locations it can access? So what is the size of the memory? Can anybody answer here? What is the size of the memory? Memory is external, and what is the range of the memory? Expected gate questions or IES questions. For 8085, what is the size of the memory? What is the range of the memory? Can anybody answer here? Good morning, Abhishek Pandit. Can you answer here? Please answer the questions. Please make the class as interactive. Please make the class as interactive. What is the size of the memory? What is the range of the memory? Can anybody answer? If I mention the address bus size is 16-bit, then what is the size of the memory? What is the range of the memory? अभिषेक पंडित बोल रहे 64 KB. Are you sure range of the memory? Then range कितना होगा? Range कितना होगा? What is the range of the memory? Can anybody tell me? What is the range of the memory? See here, size of the memory we are having 16 bit now. So 2 power 16. 2 power 16 memory locations. Always remember, one memory location can store 1 byte. One memory location can store 1 byte. So 2 power 16 into 1 byte means 8 bits. So that's why we call it as byte. One memory location can be taken as 1 byte. Okay. So 2 power 16 means I can write 2 power 6 into 2 power 10 bytes. So 2 power 6 is called as 64. 2 power 10 is called k byte. So 64 kilobytes. So what is the right answer? 64 kilobytes. Yes. Hello sir, with GATE 2025 score, I want to go in DRDO to become scientist. In that it is a good job sir, prestigious. Don't focus on the result. जो आप करना चाहते हो कर लो पहले. Which is good, which is bad वो छोड़ दो. अगर आपको गेट में रैंक आया तो डीआरडीओ में साइंटिस्ट का पोस्ट निकलेगा बोल तो वो सेकेंडरी है, पहले तो गेट का रैंक निकलना. सो आपका पूरा दोनों अंक का फोकस गेट पर रखो, रिजल्ट के ऊपर नहीं. पूरा प्रिपरेशन पर रखो, गेट का रैंक मार लो. गेट का रैंक आने के बाद जो भी आएगा अपॉर्चुनिटी, वो अपॉर्चुनिटी आपको मिलेगा. Don't focus on the result first. Please focus on the practice. Please focus on the process. Trust the process. अगर अभी 2 महीने बाकी है गेट के लिए, अभी जनवरी है, फरवरी, नेक्स्ट वीक दिस टाइम यू आर गोइंग टू राइट द एग्जाम. जनवरी फरवरी में, फरवरी 14-15 को हमारा एग्जाम है. सो 2 महीने के, सो यू फोकस ऑन ओनली द कंटेंट ऑफ प्रैक्टिस. सो व्हाट इज द रेंज ऑफ द मेमोरी? सो हाउ टू एड्रेस द रेंज? सो 64 KB is the size. 64 KB is the size. So 2 power 6 means 64. 2 power 10 means kilo. Okay. So 8085 64 kilobytes. Now what is the range of the memory? If you see, we are having total 16 address lanes है हमारे पास. So जो है 16 address lanes A0, A1, A2, A3, A4, A5, A6, A7, A8, 9, 10, 11, 12, 13, 14, 15. So पूरा 16 address lanes है. 16 address lanes से मिनिमम नंबर कितना होगा, मैक्सिमम नंबर कितना होगा, एक बार देखे तो. So कितना होगा? All zeros and all ones. Okay, so all ones means F hexadecimally it is 16. So the range of the memory is 4 zeros to 4 FH. Note kar do beta. So this is also expected gate question. Make it fast. It should not be 1111. The 1111 should be called as F. Akshita, you have to call this as F. लेकिन ये F है, ये F है, ये F है. So पूरा मिला के क्या होगा? 406 to 4 FH होगा. Why? Because 16 address lanes है ना. So 4 address lanes को 4 ones हो गया, लेकिन 16 address lanes को कितना होगा? So 4 address lanes F होगा, ये F होगा, ये F होगा, F होगा. So पूरा मिला के 4 zeros to 4 FH होगा. Okay, please, so please make a correction. So that should be 0000H to FFH. Okay. Pratik Mahesh, आप कहाँ से? No sir, already have given gate 872 is my score. With that I want to go through. Go, third year score is valid. But I am asking you, Pratik Mishra, please go for gate 2026. गेट 2026 भी लिख लो ना. आपको 3 डिजिट रैंक आ गया, 872 इज अ गुड स्कोर. बट अगर आप दिस बार इफ यू राइट वेल, यू आर गोइंग टू गेट अ 2 डिजिट रैंक. सो आई एक्सपेक्ट इफ अगर 2 डिजिट रैंक है तो आपको कोई भी पीएससी जॉब मिलेगा. चिंता मत करो. चलो, नाउ प्लीज आंसर दिस क्वेश्चन. ए प्रोसेसर हैज 20 एड्रेस लाइन्स. फॉर एग्जाम्पल देयर इज 8086 microprocessor. Then what is the size of the memory and what is the range? Range is from dash to dash. So जितने लोग लाइव में है, प्लीज आंसर दिस क्वेश्चन. टू MB नो, गलत है. मोतू पटलू गलत है, गलत. गलत आंसर है. इसका आंसर क्या होगा, जल्दी बताओ. ए प्रोसेसर हैज 20 एड्रेस लाइन्स, देन द साइज ऑफ द मेमोरी, द रेंज इज फ्रॉम डैश टू डैश. ओके, वेरी गुड. 5 कितना आ रहे? ओके, वेरी गुड. सो इट इज हैविंग 20 एड्रेस लाइन्स ना. सो 20 एड्रेस लाइन्स. So 20 address lines means what is the answer? 20 address lines. 20 address lines means it can access 2 power 20 memory location. 2 power 20 memory locations. So one memory location can store 8 bits. One memory location can store 8 bits. 8 bits means I can write byte. So 2 power 10 is kilo, 2 power 20 is mega. So answer is 1 megabyte. Okay, so the answer for this is 1 megabyte. Now the range is asking 20 address lines. So 20 address lines means what to do? 20 address lines means we can take A0, A1, A2, A3, वहां से शुरुआत करके next A4, A5. Hexadecimally, in hexadecimal we'll take 4 numbers together na, A8, A9, A10, A11, next A12, A13, A14, A15, next A16, A16, A17, A18, A19. Always remember digital 20 means the counting starts from 0 to 19. Okay, so the minimum address location will be all zeros. So minimum will be all zeros. Minimum will be all zeros. And maximum will be all ones, beta. Okay, so maximum will be all ones. So 4 ones means we can take it as F na. So 4 ones means we can take as F. 4 zeros means 1 0. So this 4 zeros means 1 0. This 4 zeros another 0. This 4 zeros another 0. In hexadecimal we'll take 4 numbers as single hexadecimal. 4 ones means 1F. So like that 1, 2, 3, 4, 5. So these are the expected questions. Okay. So these are the expected questions. Good morning. Excellent, excellent. Okay, chal. Now let us go for some more questions. So before going for the questions, let us see the register model of 8085. If you see the register model of 8085, what are the register model? Can anybody tell me what are the register model? We can also call it as programming model of 8085. Can anybody tell me what are the available registers? Programming model of 8085. Okay, so programming model of 8085, or we can call it as register set of 8085. Okay, so can you tell me what are the registers? Anybody? Up BTech में पढ़ चुका है? Excellent. So what are the registers we have? The registers we have as accumulator. This is a 8-bit register, always single, alone. And B is a 8-bit register. C is a 8-bit register. As a pair it can be BC. Next, D is a 8-bit register. E is a 8-bit register. As a pair it can be DE. Sorry, DE means 16-bit. So we can make it as a pair. Next, H is a 8-bit register. L is a 8-bit register. So as a pair it can be HL. Next comes stack pointer. Next comes program counter. इनके साथ साथ we are also having flag register, and when you club this A and flag register, this A plus flag register, then that is what we call as PSW, program status word. Program status word. So this is the complete. Yes, Madhusudan ji, आप कहाँ से हो? Anybody is having any previous ranks here? Instruction register, these are invisible registers. Very good. IR, W, Z. So these are invisible registers. That means not available for programming. Please remember this. Yes, Motu, what आपने जो बोल दिया instruction register वो भी सही है. Instruction register WZ, these are the invisible register. They are not available for the programming. Correct. चलो, प्रतीक मिश्रा जी आप आंसर कर दो यार. Yeah. Can anybody tell me what are the flags? How many flags are available? Can anybody tell me what is the sequence of the flags? So if you see the 8085 sequence of the flags, what is the flag register format? So if you see the flag register format, what is the flag register format? Whenever you perform the arithmetic operations, you are going to get certain flags. So what are the flags? So totally we are having 8 flags. So this is our carry flag, don't care. This is our parity flag, don't care. This is our auxiliary flag, don't care. This is our 0, this is a sign flag. Okay, SZAPC, this is a sequence. SZAPC, that is the sequence. Okay, so S stands for sign flag. So sign flag is equal to MSB of result. जो भी result आया उसका. Next, 0 flag is going to be set. 0 flag is equal to 1 when result is equal to 0. When result is equal to 0, otherwise. Next, auxiliary carry. So this is what we call as auxiliary carry. Auxiliary carry. So at carry at nibble. Okay. So this is the carry. Next comes the parity flag. Odd parity, even parity. Then this is the carry flag. Okay. So this is enough for us. Now with this understanding, I'm directly going for the questions. So this is enough for us. With this understanding, I'm directly going for the questions. Are you ready for the questions? Sure. Let us go for the questions. Answer this question. Make it fast. Excellent. Program counter. See, we have the PC. So PC is equal to, suppose your program starts at 1000. Suppose in 1000 I am writing instruction move immediate A comma 22. The next instruction starts from, this is 1000 address, this is 1001 address. So in memory how it is stored? No, this is the memory. So instructions are stored in a sequential address. So this is the address. So this is a 1000 address. So this is a 1001 address. This is a 1002 address. So move immediate A before comma whatever is there. This is one operand. That one opcode that will go here, and 22 will go here. So the next instruction starts at 1002. So the next instruction starts at 1002. Okay. So PC will be showing 1002. PC always represents address of the next instruction to be executed. So the right answer is option B. Okay. In a microprocessor, the register which holds the address of the next instruction to be executed. That is a program code. Very good. Let us go for the next question. Answer this question. A microprocessor with 12-bit address bus will be able to access how many kilobytes of the memory? How many kilobytes of the memory? Think and answer this question. How many kilobytes of the memory? Okay. A microprocessor with 12-bit address bus. What is the right answer for this question? Yes, Prashant Nalla. See, what is the answer here? 12-bit address lines able to, so 12 bits. So number of address lines is equal to 12. So number of memory locations. So number of memory locations will be how much? 2 power 12. So 2 power 12 memory locations. So one memory location can store 8 bits. So this is 2 power 12 into 8. So 2 power 12, how to write? 2 power 2 into 2 power 10 into 8 bit. 8 bit I can write as byte. 8 bit I can write it as byte. So 2 power 2 is equal to 4. 2 power 10 is equal to 6. So 4 kilobyte is the answer. So the right answer is option D. Excellent. Option D is the right answer. 4 kilobyte is the right answer. Chalo, let us go for another question. These are some previous year questions. Answer this. In a microcomputer, the wait states are used to dash. Microcomputer, the wait states are used for dash. Option A, make the processor wait during a DMA operation. Make the processor wait during a power interrupt processing. Make the processor wait during a power shutdown. Make interface slow peripherals to the processor. What is the right answer for this? Okay, I will give. Slowly I will give. Gate questions will give. Please answer this. In microcomputer, first we will start with the registers, then we will go ahead. Tough questions also will come, Ray, just wait. In microcomputer, wait states are used for dash. What is the purpose of wait state? So this is the microprocessor. This is a microprocessor. This is a peripheral. Suppose if this device is slow device, so this is a microprocessor. This microprocessor will give some data, and after giving the data, it should get a confirmation. The confirmation will come on the ready pin. If the ready pin is not activated, ready pin is 0. See, sometimes I will give a question and I will ask you the reason. Are you ready? Suppose if I am not getting any answer, what I will do? I will wait. Okay. So if the ready pin is equal to 0, then the microprocessor introduce some wait states. Microprocessor introduce what? Some wait states, so that the slow device can take some extra time and can complete the operation. So the right answer for this question is interface slow peripheral to the processor. That is the promise. Interface slow peripherals. Okay, so D is the right answer. Okay, done. Chalo. Now let us go for the question, programming questions. programming questions. Answer this question. So what is the answer for this question? The content of the accumulator 8085 microprocessor after the execution of this instruction, move immediate A comma A7. So first of all, what is the meaning of this? Move immediate A comma A7. A is a register that will be loaded with A7. In hexadecimal, what is A? A means 1010. 7 means 0111. Am I right? So that is first instruction. You have to understand each and every instruction. A is equal to A7, so 1010 0777. So OR A with A, this is OR operation. OR accumulator with A. So again you have to take A. A is equal to again A7, so 1010. I think those who have some digital fundamentals, they can answer this question. They can answer this question. What is the OR operation? When both, what is the OR gate? OR gate. OR gate, how it will work? So this is digital. Suppose this is X, Y, and this is the output. For OR gate, what is the truth table? So 0, 0, 0, output is 0, 0, 1, output is 1, 1, 0, output is 1, and 1, 1, output is 1. Any one of the input is 1, output will be 1. So now what is this instruction telling? This instruction is telling perform the OR operation of accumulator with itself. OR operation of accumulator with itself. So again OR operation of this with this. So 1 with 1, 1 hoga, 1 OR with 1, 1 hoga, 1 OR with 1, 1 hoga, 0 OR with 0, 0 hoga, 0 OR with 0, 0, 1 OR with 1, 1 hoga, 0 OR with 0, 0 hoga, 1 OR with 1 hoga. So this is accumulator. Next, RLC means rotate left. Rotate left, this is the carry. So right now there is no carry flag, so 0. So this is a very interesting instruction. What is rotation? Generally you are having a bit here, so you have to left. This is left, right? So from this you have to move to left and again you have to come back. So this is the rotation. So rotation means LSB has to shift to MSB and MSB has to shift to carry and again the MSB has to come back to LSB. See, in the instruction C is there, but in the rotation C should not be involved. Remember this. So that is a hint. Rotate left without carry. RLC means what? Rotate left without carry. So least significant bit has to shift to MSB, MSB has to shift to carry, but carry should not come to LSB. So how to do this? It is just like in our childhood we have played the moving chairs, rotating chairs game. Okay, so now keep this LSB empty. So move this one here. This one should come here. This one should come here. This one should come here. This 0 here. This 0 here. This one here. This 0 is here. And this one will go to carry and whatever the MSB is there, that will come again here. So the same MSB to here and the same MSB to LSB. So final answer, if you see 0100, this is nothing but 4, 1111, this is nothing but F. So the right answer for this question is what? 4FH. Option B is the right answer. ऑप्शन डी नहीं होगा मोतूलाल, ऑप्शन डी कैसे हो सकता भैया? 4F आ गया देखो। RLC मीन्स रोटेट लेफ्ट विदाउट कैरी, RLC मीन्स रोटेट लेफ्ट विदाउट कैरी। क्या रे मोतूलाल, आपने टफ क्वेश्चंस बोला, मैंने इतना इजी क्वेश्चन दिया आपको। हाँ मोतूलाल जी, sometimes silly questions are very difficult to answer beta. Thank you very much for your hearts. Thank you so much for your hearts. I'm able to see so many heart symbols. I'm always happy to see the heart symbols. Thank you, thank you, thank you, thank you, thank you, real. Yeah, thank you so much. Okay, okay. Chalo. Any other doubts? Okay, next. Let us go for next instruction. All of you are clear about this? Any doubt? Miss mat karna. So RLC means what? Rotate accumulator to left without carry. How to remember this? I will tell you. Instruction में C है ना, rotation में carry नहीं होगा. Instruction में C है, so rotation में carry नहीं होगा. Okay, चलो, let us go for the next question. Very good question. These are our previous year questions, bhai. Yeah, answer this question. Please try to answer this question. Answer this question. Move B, see first instruction 3000, 3000 move immediate A, 45H. See first instruction is this. This instruction I will write here. Move immediate MVIA. So I'll write with MVIA, comma 45H. So first instruction is the move immediate A, comma 45H. H means hexadecimal. So starts from 3000 location. Okay, the program starts from 3000. This is the address. See, this is the way how the when you are doing the lab, when you are doing microprocessor subject in the lab this program will come like this. So that's the importance of in academics you won't study, but in the lab you will see this type of programs. So what is telling here? Move immediate A, comma 45. So that means 45 will be moved to A. Next, move B, comma A. That 45 will come to register B. STC means set carry. Carry flag is set. CMC means complement carry. Complement carry. Next, RAR. Rotate accumulator to the right side now. Previously, RLC means what? Rotate accumulator to the left side. Okay, RAR. So what is RAR? Listen carefully. RAR means rotate accumulator to right side. Right with the carry. Why with the carry? I am telling. In the instruction C is not there. In the instruction C is not there, then the meaning is with carry. अगर previously in the instruction RLC है, rotate RLC है, in the instruction C है, so rotation में carry नहीं होना चाहिए. अगर instruction में C नहीं है तो carry को involve करना rotation में. अगर instruction में C है तो carry नहीं involve करना. Okay, can you answer this question? Now let us do step by step. So first goes A is equal to 45. Okay, A will become 45. Move B comma A, then B will become 45. Next, STC, set carry. So carry flag is equal to 1. Carry flag is equal to 1. CMC means complement carry. Carry flag is making again 0. STC, can anybody tell me what is this addressing mode? Can anybody tell me what is this addressing mode? What are these addressing modes? Can anybody tell me? Can anybody tell me what are the addressing mode? STC, CMC, what addressing mode? Can anybody answer this question? STC, CMC, Alt, HLT, NOP. So these all are what type of addressing modes? Can anybody tell me? 14 members are watching beta. 14 आदमी देख रहे हैं, कुछ ना कुछ रेस्पॉन्स दीजिए. What type of addressing modes these all are? Addressing modes पता है आपको? माइक्रोप्रोसेसर में addressing modes पता है? These all are gate PYQs बेटा. These all are gate PYQs. जो मैं कंटेंट दे रहा हूँ वो कंटेंट क्वालिटी. No, it's not direct. No, it's not direct. Very good. Implicit addressing mode. What addressing mode? These are implicit addressing mode. Okay. So rotate accumulator to the right. So this is accumulator. Accumulator is equal to 45. So 0, 1, 0, 0, 0, 1, 0, 1. So this is the carry flag. So right now carry flag is how much? 0. Carry flag is equal to 0. So rotate accumulator to the right. So right side rotate karna. So how to rotate this? 0 will come here. This 1 will come here. 0, 0, 0, 1, 0. And this carry will go to this one. Carry will go to this. So now carry should be involved. So carry will come here. Okay. So that means what? MSB will go towards LSB. LSB will go towards carry. See, the carry is involved now. Carry will come back to MSB. It's a beauty. MSB will go to the LSB. LSB will go to the carry, and carry will come back to MSB. Okay, na? So like that it moves. It moves like this. Okay. So finally, what is interesting thing here is, this is now A. This is A. So what is A now? A is equal to 0, 0, 1, 0, 0, 0, 1, 0. Am I right? Chalo. So what I have done, I have moved to right side. 0, 1, 0, 0, 0. This one will go to the carry. This one will go to the carry, and the carry will come back like this. 0, 0, 1, 0, 0, 0, 1, 0. So now I am performing XOR operation with B. So what is the B? B is equal to 0, 1, 0, 0. 5 means 0, 1, 0, 1. Okay. So when you are performing XOR operation, what is XOR operation? When both are same, output should be 0. Otherwise, output will be 1. So here 1, here 1, here 1, 0, 0, 1, 1, 0. So what is the answer? 67. So this is the answer. So answer is 67. Option C is the right answer. How many of you got the answer, beta? Option C is the right answer. Did you get it, Motulal? Option C is the right answer. Clear or not? Yes, implicit addressing mode. Chal. Now let us go for another question. Wait. Answer this question. इसका आंसर बताइए यार. The 8085 microprocessor has a register content SP. Stack pointer is given as 5FF 8H, and the register B is given as 34H. Register C is given as 7FH. Before the execution of instruction push B. So very interesting instruction. This is push B. What a push B instruction will do? Push will push the contents of the BC register pair. B alone will not go. B is having a pair, na? So always respect the partners. So B is having a pair called C. So B and C will together will push into the stack. So this is what we call as stack. So this is my stack pointer. So this is my stack pointer. So what is the stack pointer was telling? 5 FF8. So when you push, what happens? The very first step is the stack pointer is decremented by twice. The stack pointer is decremented by twice. So this will become 5 FF7. This will become 5 FF6. So this is a new top of the stack. Then the lower content will go to the lower. The upper content will go to the upper. So 7F will come here. Lower berth will go to the lower. Higher berth will go to the higher. So B is upper. Here B is up. 34 7F. So now what is the question? The value of SP and the content of the stack top after the execution of the instruction. So the value of SP is this 5 FF6. So 5 FF6. So first of all ये 5 FF से ये दोनों cancel कर सकते हैं. ये दोनों में answer होगा. And what is the content of the top of the stack? 7F. So right answer is option C होगा. क्या हो गया यार? आंसर नहीं आ रहा आपसे? ऑप्शन सी है आंसर. Okay, चलो. Now let us move for the next question. Yeah, answer this question. Which instruction is an 8085 processor can set a flag? Move B, C, JNZ 2100H, STA 2000H, add B. Move B, C. The contents of the C are moved to B. So this is a data transfer instruction. Data transfer instruction will not set the flags. So what is this? This is a data transfer instruction. Data transfer will not set the flag. So it is wrong. Next, this is a control transfer. After flag set or reset, this instruction will work. But what the question asked is which instruction can set a flag? So this cannot set a flag. So this is also wrong. Next, STA, the contents of the accumulator are travel to the store accumulator, travel to this memory location. So this is also memory transfer. So add B. So when you add contents of the A will be added to the A, B will be added, and the result will be stored in A. Definitely flags are going to be affected. Sign flag, carry flag, zero flag, parity flag, auxiliary flag, these all are going to be affected. Okay na? So the right answer is arithmetic instructions. Arithmetic instructions will affect the flags. Arithmetic instructions will affect the flags. Okay va? Chal. Next. Answer this question. Make it fast. Last question for today. What is the answer? The instruction in 8085 processor can clear the accumulator. C contents will be moving to B. So this is not. Jump if not 0. Jump to memory location. Memory 2100. So this is also not. Next, store accumulator. The contents of the accumulator are traveling to 2000 location. So this is also not. XOR A with A. A XOR with A. The answer is A XOR with A. What happens? A XOR with A. So the answer will be 0. So will be, so option B is the right answer. So, okay, enough for today. In the upcoming classes, I will take more content because it's the beginning class. Okay. So please follow my regular classes, will be more benefited. Okay, enough for today. Thank you.